Today I'd like to go over T number 9. All right. So we have for positive whole number n, the value of n plus 5 over n squared plus 10n plus 100 can be written as p over q, where p and q are relatively prime positive whole numbers. And we need to find the smallest possible value of p plus q over all positive whole numbers n. So we kind of want to simplify this fraction into something that we can work with. But in this form, the n plus 5 over n squared plus 10n plus 100, we can't really write it in a really simplified way, mostly because the numerator is a degree 1 term, and the denominator is a degree 2 or quadratic term, quadratic polynomial. And we see that we can't really simplify this because n squared plus 10n plus 100 isn't exactly factorable. And so we need to write it, consider a different form of this fraction, mainly its reciprocal. So we're going to turn this into n squared plus 10n plus 100 over n plus 5, and then we can probably see some simplification. The reason why this works is because the smallest value of p plus q, when we simplify it, when you take the reciprocal of it, it's still going to be in the simplified form. So we can get away with doing something like this. So we can write n squared plus 10n plus 100 in a kind of completing the square fashion as n plus 5 squared, writing in something in terms of the denominator. And then we have left over 100 minus 25, because 5 squared is 25, that is 75. This still preserves equality. And we can cancel out the n plus 5, splitting up the fraction, and this becomes n plus 5 plus 75 over n plus 5. Note that since these are since p and q are positive whole numbers, we can make a substitution. Let's make m equals n plus 5. Then we can write, this basically turns into m plus 75 over m. And when you simplify this, we need this so that this is in simplified form. We don't know what m is. M could be any integer. And when you evaluate m, you'll get initially some unsimplified fraction that you need to simplify. We don't know what that is, so our sum is actually going to be m squared plus m plus 75. Both m squared plus 75 and m are going to have going to share some factor, mainly m and 75. And so this is what we need to minimize. In order to minimize this, we need to maximize this at the same time minimize this. As it's a fraction, since there's a numerator and denominator, the numerator, if you want it to be small, the numerator needs to be small because that's your top term that you're multiplying. And then since you're dividing by something, you want that division to be as maximal as possible. So when you divide one number by a larger number, that becomes a smaller number. And so here we see that with the greatest common divisor of m and 75, this set is actually you're going to get all the factors of 75. That's going to be 1, 3, 5, 15, 25, and 75. We can see that from here, we kind of want to focus on these last few, because here we focus on the first few, you're not exactly going to get the minimal sum of p plus q. And so we see that we focus on 15 plus 25, 15, 25, and 75. We see that if m was 15, then you get 15 squared plus 15 plus 75 all over 15. We get here 15 plus 1 plus 5, that is 21. That's our p plus q. If we do m is 25, we get 25 squared plus 25 plus 75 all over 25. That is 25 plus 1 plus 3. That is 29. And you can kind of see from here that if our m's get larger and larger, our sum is incidentally going to be larger, consequentially going to be larger as well. So we can kind of see that you can solve it this way. We get 21. We can also solve it using a brute force way, just evaluating the first 5 or 10 whole numbers of n, and you'll probably get the correct answer from there. Since we're asked for the minimum, you could just brute force all of that, all the minimum whole numbers, and you'll get your minimum, because as you go up in the whole numbers, the fractions get larger and larger, your numerator and denominator gets larger and larger, and so your sum will get larger and larger. So your minimums will occur. You should mentally check that your minimum is going to be somewhere in the beginning of the whole numbers, and that's it for this problem.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.